Okay, welcome to the columns the limit, interactive laptop large data analysis with Buckaroo and Polars. I'm Paddy Mullen. I've been in the PyData space for a long time. I was an early employee at Anaconda where I worked on Bokeh and Wakari, which was our early Jupyter Notebook sharing system. Worked with Python in a variety of places. So we're going to go through an intro. There's going to be a quick demo of laptop large data. So by laptop large data, I mean data that's about the size of the memory on your laptop, and data that if you don't do the wrong thing with it, your laptop will crash, or your Jupyter kernel will crash. A tour of Buckaroo and why I built it, talking about the approach, walking through Buckaroo's approach to large data, demo time, adding your own analytics, and then if we have some time, going through Polars and the extension to Polars I wrote, and some cool other things you can do with this. So let me just start with showing you what I'm talking about. So this is Buckaroo reading in a 19 million row file. This is a Parquet file. It's about 450 megs. So here we are at row 11 million, and here we are at row 19 million, and we have summary stats up here. Just a couple. We have some histograms, unique, null count. We're going to be talking about how I built this experience and why I built this experience. That was cheating a bit. Let me show you with the cache cleared and watch it process in the background. Takes a little bit of time, but we are still interactive here. So we can execute a cell, and we haven't killed our Jupyter Notebook. And we see those summary stats populating through. So, okay, back to the presentation. So here is life in Pandas world. And Pandas is great, but this is what you get in a notebook when you look at a data frame with Pandas. You see the first 5 rows and the last 5 rows.
Can you enlarge a little bit? Thank you.
And then this is a data frame about city bike trips from a place to a place. We can sort values here. And now we've sorted by trip duration, and we see like these were our longest trips. We can run summary stats. And here are Pandas summary stats. We can even see a histogram. Do I have matplotlib installed? I do. And there's a histogram of trip duration. Let me show you the same experience with Buckaroo. Here's that same data frame, and we can sort. We can look at summary stats. We can search, Pershing. And you see we went from 100,000 down to 2,800 rows. We can scroll left and right. And notice the things we didn't do. We only have one cell here. We haven't cluttered up our notebook. Also, we just read in the data frame. We didn't go over to a different environment. Pandas is great, and Pandas was a real advancement when it came out. But Pandas is built for step-by-step processing, batch processing, and there are interactive elements to it, but that's not what it's built for. Buckaroo is a library built to help you quickly understand your data. It helps you look at your data, which is, in my opinion, the most fundamental part of data analysis. If you don't look at your data, you're going to make mistakes. At one point in my career, I was reviewing a model with a trader. And we didn't like the result it was giving, and there were like 5 or 6 lines of code. And I was reviewing it with him, and I'm like, OK, well, at this line, we make this transformation. At this line, we make that transformation. And we're going to get to the answer here. And like, which part don't you like? And he said, well, what does the data look like? I'm like, well, it's one of these transformations. He's like, what does the data look like? And he wanted to look at the data at every step. And like, they would really drill that into my head. When you have tools that make it difficult to look at the data and look at the histograms and all the summary stats you know you should be looking at, you skip that, and then you regret it. And our tools should enable us and encourage us to do the right thing. Let me show you a little bit more of basic Buckaroo. So, forgot to ask you all questions. Who here has used Pandas? Who has used Jupyter? Who has used polars? Okay. Who has crashed their Jupyter kernel? who has taken a data frame and gone out to Excel to look at it in a better tabular view? Okay. Who has used Buckaroo? This guy. Thank you. That helps me figure out what to talk about here. Same data frame, pretty much the same things here. And we're going to do something slightly different here. We're going to create a widget. Buckaroo is extensible. And what we did right here, this is a simple function that takes a data frame and returns a data frame, and we're looking for the outliers in any column. So if you're a numeric column between the first percentile and 99th percentile, include that index and just return the DF with that mask. In Buckaroo, that is now turned on as the outliers function. And that was like 6 lines of code to add. You can turn it on. When it's off, this data frame has 100,000 rows. When it's on, there are 44,000 rows. I like opinionated analysis. And when you have a general tool, you generally don't want an opinionated analysis because that might not work for every use case. But when you can change the opinions and the views in the data quickly, you can have opinions. This is the type of like little utility function I write all the time in notebooks. And then you throw it away in the next notebook. And like sometimes you'll just have that and that's a cell. But you can build up your own library and just toggle them on and off when you want to. So here are some other things we can do with Buckaroo. We can color this column. So here the float column is colored based on the int column. And then if you sort by int, you just see you get this nice gradient. Oh yeah, we have, so these are regular histograms, which don't make a lot of sense here. And then we have categorical histograms. So I have this space for histograms in the UI, and histograms don't make sense on string and object values. Let's go back up to the city bike data. So I came up with categorical histograms where it shows the most frequent value, the second most frequent value, and then there are some other pieces like long tail values. So if you have, like, I think it's less than 2% of values and they occur at least twice, that goes in the long tail. There's another bar for unique, and then we have a bar for NA. And this lets us just look at the data quickly and try to figure out what's going on here. When I showed this to one of my friends early on, and he said, you should rename the columns. Those are kind of hard to understand. And I said, no, I'm not going to do that because this is how you see data a lot of the time. You get data, you have no idea what it looks like. And you have these column names that make no sense. You need to make sense of it. I built Buckaroo for me. And I'm not a data scientist, but I look at a lot of data. And I get about like this far in analysis. I've done a regression. I've done other pieces. But as a software engineer, I was really annoyed with the experience in the notebook of let me re-execute this cell, let me try this, let me try that, and I knew there was a better way. And Buckaroo is my view on here are some better ways of doing this. So, as the creator of Buckaroo, nothing that I've done you can't do yourself. You can extend this all at runtime, as we have here. You can't write your own chart displayer, but you can access the chart displayer that's there. And I'm not going to go through how this customization worked, but here we've created a data frame with chart values, and we're displaying it inside Buckaroo. One of the key things with Buckaroo is when you import it, it becomes the default data frame display method. And you can turn that off. Some people have said, no, you should have to call it. But you look at data frames all the time. Like most notebook cells end with DF, so you look at the data frame. You should have a better experience for that. But that means a lot when there are a lot of data frames out there. A lot. And I've run into bugs with a bunch of these. Here's the multi-index data frame, and Buckaroo renders it properly. We have 2 and I forget exactly which one this is, but it's a multi-index with names and yeah, I forget which one that is. Really big numbers. Sometimes, if you don't do the right thing, if you send a big int into JavaScript, JavaScript will just crash or not like it. Or sometimes JSON parser will crash. I forget which things crash, but it doesn't anymore in Buckaroo. The same with infinity and nan. So there are all these different types of data frames that you might not run into them that frequently, but you will run into them. And I don't want to deliver the experience to Buckaroo users of, I tried to display this data frame, and it just crashed or displayed nothing. Buckaroo runs in most notebook environments. So we're in Jupyter here. Here's a screenshot of it in Marimo. I'm going to show you a little bit more there. It runs in Colab, VS Code, and yeah. That's important because you can extend Buckaroo. All of those environments have some type of data frame viewer on their own. Marimo's is open source, the rest are closed source. None of them are extendable, and none of them are meant to be extended. So invest into your tools. And it's worth it to do that with Buckaroo because there are going to be different notebook environments you run into, and you can probably take Buckaroo there. Buckaroo is built on a series of technologies that already existed. AgGrid provides the table. There's pandas and polars. Jupyter and Jupyter widgets. Any widget. Trevor Mans wrote that, and if he'd written that 3 years ago, Buckaroo would be 3 months ahead of time. It's a lot easier to use than Jupyter widgets. Recharts for the charts, SQLite, High Parquet for JS deserialization of Parquet, and Cloud Pickle. Let's look at a couple of other things. Here's a little app I built to join 2 data frames and compare them. So you can see which rows exist in only one data frame by coloring, which values are the same. And it's cool, this is actually running in Marimo. And then, this is one of the harder parts to explain, but one of the parts I'm most proud of. I spent a lot of time cleaning data. You look at data frames, and you can, here's a data frame with column with floats, column with, they look like ints, but you have B9, you have 867-5309. So Pandas has to treat this as an object column. You have US dates, but 17, there was not a 17th month in 1982. And this looks like Booleans, but you can't treat it as Booleans. So first of all, there's a low-code UI in Buckaroo where you can click on columns, like fill NA, and change this value, and you get the Python code here for, okay, there's fill NA there. There's a series of functions that are applied like a timeline in CAD software. And that's one thing you can do with the low-code UI. The low-code UI is also built into auto-cleaning. So auto-cleaning takes a look at columns and says, what could this be, and what, like, is mostly ints, could I apply a Boolean transformation to that? Could I apply a date transformation? And then it gets a heuristic score and says, no, it gets a fraction. And then via heuristics, it says, what's the threshold for which function I want to apply? And it applies one of the functions. And then you get the Python code for that. And then you can try, once again, you can be opinionate. You can have different opinions about how you want to look at this. And you can say, well, I want a higher threshold, and we're only going to do Booleans. I know how to write all these pandas commands. I'm sure you all do. Sometimes when I'm really serious, I'll look at a Matt Harrison book and look at the beautiful way to write it. I don't want to type all the time. So let's come back to, I've talked a little bit about this, but like the use case for Buckaroo is different than other table libraries. Buckaroo is built for the interactive case, and it is configurable, but it's not meant to be configured every time you touch it. So I would say most table libraries are built to produce a really highly stylized table that you've put a lot of work into. And like this is going to be for a presentation. Buckaroo is not built for that. Buckaroo is built for the first time you look at it, and let me interrogate the data and see what's the best view to apply to it. You have to make trade-offs for like how do you deal with more data. df.head says, let me show 5 rows, first 5 rows, last 5 rows. You could do sampling. Sampling ends up slow. You can manually paginate. You can say no trade-offs. We're going to calculate everything. Why data profiling does that, and why data profiling delivers an HTML report, and it takes about 3 minutes to run. It's a much better statistical report than anything I've done, but it's a different use case. You could say, we're going to let the user decide everything that they want to do, and then we're not responsible if we crash their machine. And that's fine. You can do one of those things. Buckaroo chose differently. A note about the styling of Buckaroo. This doesn't look like most modern apps. There's a reason for that. I think there are kind of 2 types of styling. There's VC UI, and then there's Trader UI. In VC UI, you have nice rounded corners and lots of padding and gradients and colors. And you're going to have, the biggest table you're going to have is going to have 3 columns. And at the bottom of column 3, it's going to say, call us for pricing. And then there's Trader UI. And if you've worked with a trader, they're going to jam information into every single pixel on your screen. Trader UI is respectful to your screen real estate, and I want it to be respectful to your screen real estate. So we're getting to the lazy processing and how Buckaroo does large data sets now. Everything we've seen up to now, Buckaroo filters at, I think, over 100,000 rows in pandas. And you have to cut off somewhere. I cut off at 100,000. You can cut off wherever you want. But you want to be interactive. So this summer, my cousin called me up, and he's like, Paddy, I have this large data file that I can't open in Excel. He was doing marketing to doctors, and he found a list of doctors, and he wanted to look at it. I'm like, okay, this will be easy. This will be really quick. He's like, and I open it up. It's a 10 gigabyte CSV file. And I'm like, oh, no, this is actually a problem. This is an interesting problem. I looked at it. I put it into pandas, but like pandas was not great for that. I think I ended up doing some greps for like the things he was looking for. And like we had a phone call. I walked him through it. It was like, oh, this is not what I'm looking for. This is not the data set I'm looking for. But that's important, and getting to that answer faster happens all the time. Like in the data analysis I've done, like most of the time I'm like, oh, that data set could be cool, but it's not actually useful, and you want to find that out faster. Dealing with that data set, though, was a pain. And like I was going back to old world where I have to type this command, then try this, then try that, and I couldn't have my Buckaroo experience. So when you deal with large data sets, what you generally do is like, let me try importing this. You crash your kernel, or something runs really slow, and you don't know if it's going to finish. And you're like, OK, well, let me try it on a smaller set. You try that, and then that works, or maybe it doesn't, and then let me try it on a bigger set. Oh, let me try this performance tweak. And then you spent a couple hours, and you're like, oh, it's like a little video game. I can try this, I can try that. But you're not actually doing the real work you want to do. You want to look at the data, and you're not doing that. You're just playing around with like tweaking little parameters. I wanted a better experience. So let's see. I'm going to clear the cache, and then I'm going to talk through how Buckaroo deals with the data, like what it's actually doing in the background here. To deal with a large data set, you need a couple of things. You need lazy loading of the data between the front end and Python. So for those of you not familiar, your Jupyter notebook here, we have a Python kernel running, and then we have JavaScript in the browser running. When I scroll this here, you see how it's empty and then it fills in. That's the table saying to Python, I need data for these sets of rows. And then they're populated. And that's working on this data frame, and Buckaroo until last week worked on data frames where the whole thing was in memory. For larger data frames, you don't want to have the whole thing in memory. Next thing you need is lazy loading of data off the disk. So polars, which I'll get to in a bit, Polars can do lazy frames, where it says, here's a pointer to the data frame, which is probably back on disk, and we don't have to load the whole thing. We can run a query on it and then explicitly say we're going to load just the amount of information we need to answer that question. To make the scrolling work without any summary stats, instead of Buckaroo saying, oh, here are those rows from the data frame, it just says to Polars, okay, you have your lazy frame, go read that bit from disk. You need reliable execution of background processes with timeouts. There's no way to say with polars or pandas or regular Python, run this function and return in 3 seconds or fail. And I don't care why you fail. I don't care if you crashed. I don't care if you ran out of memory. I don't care if you just didn't finish. You can't do that. And then caching of computed values. So this took a while to compute, but I don't really care as long as I don't have to wait for that to compute again. And it's not that hard to cache the value. Shouldn't be that hard. They're tricky bits. The last thing, so I built all of that into an execution framework. You want to keep track of what you've done. So like if you're back to the world where I'm playing with this large data set by hand, like you're probably going to end up with a text file on the side where you're saying, okay, I tried this, that worked, I tried that didn't work, because you're going to crash your kernel, and then you're going to lose all state. Doc, it hurts when I do this. Don't do that. You need a log to keep track of what you've done to not try it again. And then there are other ways you can try approaching the same problem without necessarily crashing, especially if you're running out of memory. Okay, let's watch this again, and I'm going to kind of explain what Buckaroo is doing. So this is a debugging tool. When lazy Buckaroo loads a large data frame, it first tries to execute the first 6 columns, and that failed. And then it tried 13, then 1, then 2, then 4, and 8 sometimes passes, sometimes fails. But there is, yep, we got a failure, and then it's going to try again. And there's a function you can plug in your own strategy for dealing with that. Like, this is pretty dumb. You can look at which expressions were faster or slower, and how long do I think this will take. But like, this is one of the ways that you have a chance to do stuff. Let's just tab over to Activity Monitor. Oh, good. We're only at 8 gigs of memory used on my 16 gig machine. Let's add a stat to this at runtime. So right now we have histogram, unique count, null count, empty count. Let's add a summary, a sum. So every numeric column, just take the sum of it. We have a reference to the widget, widget.addAnalysis. So we have the sum column. It's not going to do anything until it gets probably over here, because you can't sum strings. All of this is computing in the background. This is a diagram explaining the execution strategy, like how it tries more columns, backs off, or not. Adding that summary stat, one of the things I've done in notebooks over and over again is I want to run this series of statistics on these columns. And I have a list of functions and a list of columns. And like, oh, I'm going to write a couple lines of Python, iterate over my functions, iterate over my columns. And that's really cool. And you get a dictionary back, and that's great. Until it blows up in the middle of 2 for loops. And then you're like, what column was it? What function was it? And I wanted something better. So a lot of times you're going to want a function, like one measure that depends on another. Variance is an example of that. So I wrote a little DAG, directed acyclic graph, and you can say, Variance depends on mean, and here's the Python code to run that. And the pluggable analysis framework makes the graph for you and makes sure that mean will be available by the time it calls this function. That's nice. Let's see, how are we for time? 10:10. Okay. Who wants to see a little bit about polars and like how polars expressions works and the lazy stuff for polars? Okay. So, please work. I just didn't know if my environment was set up right at that point. Here's a polars data frame. Looks a lot like a pandas data frame. And one thing to note is I'm not using Buckaroo here because sometimes there are better libraries for better things. For just showing like simple examples like this, the default HTML view is better. Okay. Polars says, here's a data frame. What expressions are we going to apply to it? And pl.all is saying for all columns, apply a hash function to it. And df.select, and it executes that. The built-in polars hash function is element-wise, so it gives you a hash of each value in each column. For Buckaroo, I wanted a hash of each series so that I didn't have to recompute on each series. So I wrote a polars plugin to do that. And we can execute that. HashXX is supposed to be a very fast hash library. You can run multiple expressions at once. So here we're going to take the series hash, and for all numeric columns, we're going to take the mean. And it does that. Lazy frames. So polars has lazy frames, which I've talked about. It's kind of like a pointer to a file, and you can kind of see like here are the operations we're going to apply to this. So where was I? Okay. For this data frame, like our initial data frame, let's take the length of that. Each column says 3. For the city bike trips Parquet file, 100,000 rows there, and like each one returns 100,000 rows. But at no point did scan Parquet load all those 100,000 rows into memory. It just went through each column, read it, and then threw out the rest of the data. Like it uses a lot less memory. And you can also apply slicing to it. So here, scan Parquet city bike trips, slice 0 through 5,000, grab the length of each column. And it returns 5,000 rows for each one. This is what's going on with the lazy loading somewhere in Buckaroo when the front end calls back. So it's a little bit of polars. Since we can reliably execute things in background processes and we don't have to worry about our main Jupyter kernel crashing, there's a lot of cool stuff we can do. Imagine you have this query on a data frame. Your data frame looks like these. These red dots are going to cause a failure, and we want to narrow down to where that failure is happening. So calling sum, mean, and buggy. What column does it occur on? You can say, well, let's try A and B. Those pass, C fails. OK, we know the problem's with C. Our expressions. OK, sum passes, mean and buggy fail. Mean passes, buggy fails. You can start bisecting the rows to get a row range, so you can write a nice bug for your library creators. This is really tough when you have to restart your notebook every time and like keep your notes in that little file on the outside, like what rows were failing. If you can reliably execute and you keep track of what you did and what crashed, you can have a piece of software do that for you. And then sometimes you can do a sampling of the rows where you're just like, okay, take a sampling, does this fail, does it pass, and try to figure that out. There's also a lot of opportunities for profiling, which I am not doing yet. Yeah, we're getting close to the end here. Let me show you the original data set that my cousin had. 9 million rows, there are 330 columns, and we're going to clear the cache. And yep. Okay. So we can scroll through here. We can scroll through here. We're at row 6 million, and you can go over and you can see all the rows. Eventually, these analytics aren't going to work, and something's going to fail. I haven't debugged that yet. Our notebook is still working, though. Let's look at our memory usage. Okay, that was a background process that did some processing there, and then it was killed. And we haven't lost our kernel. Yeah. So that's pretty much my presentation. Look at your data and use tools that let you look at your data. If you want, if you have a problem with looking at tables, please call me. I might write a whole feature about it. I like hearing problems from users. It makes what I'm doing much more real. Pip install Buckaroo and check it out on GitHub. Give me a star on GitHub. File some bugs. Oh, sorry, here's 100 million rows. That's the largest thing I have on my machine. Yep, 58 million. Yeah, 88 million. And let's look at memory. Oh, our background processes died. We're down to 9 gigs of memory used. Thank you. Questions?
Any luck getting into Conda at some point?
Not
to start a religious battle here. But.
No, I haven't tried. Is that key for your use case?
Might be nice to have.
Okay. If it becomes key for your use case, please get in touch. Yes?
So I think you showed primarily things kind of working with local, local files.
Mm-hmm.
I'm just curious, would it be possible to, or does it support either one files on S3 or kind of in the future visualization of things that are living in your database without pulling it locally?
I haven't tried. S3 should be a lot easier because I'm pretty sure that I've read about pollers doing stuff where it's going through S3 and doing row range stuff, or I know that there are lots of Parquet readers that do that. Your database, I'm less sure about. Oh, one of the things with Buckaroo is you're staying in your Jupyter environment. We're not going out to Excel. We're not going out to a database app. We're not going someplace else. It meets you where you are. There are ways to build that experience around data warehouses and databases. I just haven't had that use case, so I haven't done that yet. If you do, come talk to me.
I was curious as to whether you've tried this with any GPU acceleration, just to see how far it goes.
I just talked to someone from NVIDIA about it, and I was like, I don't know that this is applicable to me because the latency matters a lot. And what he was telling me is that, first of all, GPUs can read off of Parquet, which I hadn't realized. And then with this new execution framework, you're sending back very little data. Somewhere in the logs, the largest the cache gets through this whole demo is 100 kilobytes. So not yet, but you could. And that's going to be kind of more dependent on what Polars gives me, unless I go and make a custom backend for it.
I was a few minutes late, so I'm sorry if I missed this, but I was wondering how this relates to inferring a schema or enforcing a schema, because a lot of times what you do if you're reading a CSV file, it's this is probably a string, but you're not sure. And it looked like some of the functionality you were showing was inferring a schema, but I didn't see any explicit schema definitions coming out.
So a couple of things. There are no explicit schema definitions because this is optimized for the use case of I've never seen this data before.
Right.
And it does whatever Polars does by default. I haven't done anything smart there. The cleaning bit you saw is a subpart of Buckaroo for data cleaning. It's not like that's not the regular workflow through Buckaroo. That's based on like, hey, you have this data frame, and like Buckaroo takes the view that like you have this data frame, kind of how do you make sense of it?
So the output of that, sorry, just to follow up. So the output of that cleaning you did, I mean, I saw you got rid of nulls and other things, but can that wind up with something that in memory, at least on some of the columns, is an enforced type? Or not really?
Not really. I have a demo where I plugged Buckaroo into Pandera, and like, here's your Pandera validation. Here are the actual cells that failed that validation. They're colored differently. Buckaroo isn't really meant for that, but it's close to that stuff. And I'd love, like, that cleaning UI is my favorite part of Buckaroo, but it's like the least used part because, like, I just want people to stop using df.head. Like, start doing something better with your data. And like, once people have done that, and then they start asking for more, then they'll kind of hopefully move over to the cleaning UI. But I'd love to talk about that stuff with you or other interested people.
Given the smart things that Buckaroo is doing to like render the data and maybe filter or clean the data,
Yeah.
is there a mechanism by which you can say, hey, I love this, or I like it, maybe I don't love it, but I like it enough. I want the Buckaroo version to then serialize that, to then have Buckaroo not just be exploratory, but also act as the intermediate filter that can then give you like a persisted version of what Buckaroo's then showing?
I think it's possible to build that experience. Buckaroo is not really built for that. Because of the way it's done lazily, like that's just between the front end and Python. Like what I would do to do that is persist like if you wanted to save to HTML, I'd persist a Parquet file with like, here are all the rows that you needed for this experience. But you're not gonna be able to sort, you're not gonna be able to search because it's just like, here are the rows that we have. None of the sorting or searching happens in the browser.
Right. What I'm saying is like beyond, once you're done looking at it and you say, hey, I like what Buckaroo's done, either from built-in functionality or I've added in my own filters or my own cleaning functions. You're like, this looks great. Now I want to persist this to disk. I want to like create the snapshot of the Buckaroo version. Like, that would be a pretty cool feature.
Oh, well, yes, you kind of can. Okay, there's another way of answering that question. Let me find that notebook. Okay, we're going to search for Pershing. We're going to turn off outliers. We have 2,800 rows. So this Buckaroo widget we had a reference to, and then we can just put in a new cell, bw.dataflow.processed.
Awesome.
So this is just the 2,800 rows as its own data frame.
Yeah, very cool.
Oh, I think you asked that question earlier. Yeah, so you can get to that. Please, if you want to use Buckaroo and you can't figure out how to do something, get in contact with me. File a bug, reach out to me on LinkedIn. I love hearing from users, and I love hearing use cases, even if it can't do it. Like, makes the work I do real.
So one thing that you mentioned is like, if you had to do something, maybe you'd have to write like a custom backend or something. So just following up on that, like how difficult is it to add a custom backend? Like, is it fairly extensible from like pandas to folders to add another custom backend?
You'd probably want to work with me to do that. It's not that easy. My thoughts on that are, first of all, there's narwhals that's come out, which is kind of a universal data frame API that deals with lazy stuff. I would either do narwhals or I would do IBIS. And IBIS can query to a lot of data frame backends. One of the reasons I didn't do that was because really like the low code UI, and I like the code generation there, and like you want it to look like native pandas code. And yeah, that's why I didn't start with those backends, but you definitely could do that. And if you want to, like, get in touch. In the back?
Yeah, following up on his question about like, okay, you do all this cool manipulation, right, all in one cell.
Yep.
And then you want to start with that. Is it possible to convert that to, or just like the simple part of that, like the data that's in the rows without all the roll-ups and stuff like that, to a pandas data frame? Or some other object?
We did that here.
Okay, that's what you,
So
I wasn't sure.
you're referencing the way old Buckaroo worked, which is still available and still useful, is you have this Buckaroo widget and you start with the input data frame, then you do a series of transformations to it, and then that process data frame is what you end up displaying. And you can reach in and get access to that process data frame. So right here we could just say, there we outputted it, but we could say .to Parquet, temp.park. You could do that if you wanted to.
So processed underscore df is a pandas data frame.
In this case, because we started with the pandas data frame.
I got it. Thank you.
Sorry, one more question. Because of the reactivity of the Jupyter widget, is there a world in which, and I don't even know how this would work given your answer to that gentleman's question for the backends that you're connected to, is there a world in which either now or in the near future, Buckaroo could be responsive to underlying data changes? Like there could be some hook that if the underlying data updates, then dynamically the Buckaroo visualization changes.
So the first place I've run into that, there are a couple of answers to that. This little execution log here is really ugly. Like there was a whole splash of content because like Buckaroo is not built for updating your data frame, and like, so that's step one. Like I could build that out. I've kind of like looked at like what JavaScript API calls would I make to do that. That's answer one. Answer two is, what is the streaming data frame format that's the most popular that would like be good to build on top of for that experience? Like I don't know. Like I know that streaming data exists and streaming data is used in Python. I just haven't come across it yet.
Time for like one more quick question.
Sure. Anyone? Cool, thanks for coming to my talk.